On linear equations and two variables. So this corresponds with section 1.3 in the textbook if you guys want to use 1.3. All right, so the slope formula. So it says the slope m of the non-vertical line is m equals y2 minus y1 over x2 minus x1. Good with that? Slope-intercept form is y equals mx plus b. Point-slope form we're going to be using more often, especially next year when you guys go to AP Calc. That's going to be y minus y1 equals m times x minus x1. The reason that we use that more often is because sometimes we have really gross things like 31/7 and -3/4 and a slope of -211 over 3, right? Do you want to find y equals mx plus b with that? No. Wouldn't it be really easy to write y minus a -3/4, so plus 3/4 equals m, which is -211 over 3 times x minus 31 over 7? Isn't that a lot easier? Done. That's an equation of a line. It's just in a different form than you're used to, okay? Parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines are opposite reciprocals of each other. So if I have like a slope of -3/4, so I'll call that M1, like slope 1, what would the slope of the second line have to be? 4/3, right? Positive 4/3. So it's opposite, meaning opposite in sign. Reciprocals means you flip it around. Hopefully this is all just big review. So number 1, so it says passing through the point 3, -8 with slope of 6. So we can write it in slope-intercept form or point-slope form. So wouldn't it be really easy for us to do y minus a -8, so plus 8, equals m, which is 6, times x minus 3. We're done. In AP Calculus, which hopefully you'll take next year, some of you are seniors, so sad. But if you take AP Calc, you leave it like that. Because if you go further and you make a mistake, then you would miss that point. You wouldn't get the point for writing the correct equation. So we just stop there. So circle it, done. So passing through the point 4, 2.8 with slope of -1/2, you would just do y minus 2.8 equals -1/2 times x minus 4. And you're done. Now, could you simplify it into y equals mx plus b? And sometimes you would need to because maybe you're taking the SAT or something, and maybe it's only in that other form. It's only in y equals mx plus b. Well, could you get it in that form? Yeah, you just multiply in. So you can multiply that -1/2 in. So you'd get -1/2 x plus 2. And then you would add the 2.8 to both sides. Now that you guys are in pre-calc, I know that I don't have to write these transition steps, right? Do you guys agree? I don't need to write all those steps. So I'm not going to write those. I'm just going to add the 2.8 over. So I'm going to say y equals -1/2 x plus 2 plus 2.8, so 4.8. So it's pretty easy to get it into that form. Still feeling pretty good about this? You're like, yay, hope pre-calc is always this easy. Disclaimer, it's not. I'll make it easy. I'll make it easy for you, right? All right, so passing through the points 4, 3 and -4, -4. So both of those equations had the slope for you, right? So both of the slope-intercept form and point-slope form had the slope in them. This doesn't have the slope. So if you don't have the slope, you always have to find that first. So our slope is going to be the y2 minus y1 equals x2 minus x1. So -4 minus 3 over -4 minus 4. So we get -7 over -8, which is 7/8. Okay, so you can do slope-intercept form, or you can do point-slope form. I would just do point-slope form, right? That's a really easy one. So I'd say y minus, and it doesn't matter which one you use. I would accept both as solutions. So you can do y minus y1 is 3 times x, or equals m times x minus x1, which is 4. And just leave it like that. That would be good. Usually on the test, I do make you write it in y equals mx plus b. Do you guys know why I do that? Not for graphing. It's purely selfish. It's easier for me to grade. Because when it's point-slope form, I have to look for the 2 different possibilities and also slope-intercept form. So it's just easier for me to say, write it in slope-intercept form. Isn't that mean? All right, so number 4. So parallel to line 4x minus 2y equals 3. So this one we don't know what the slope is, but it's kind of in there. So we want to first write in the y equals mx plus b form, because the m is going to be our slope, right? So we're going to subtract that 4x over, so I have negative 2y equals negative 4x plus 3. So I just subtracted the 4x over. And then I'm going to divide everything through by negative 2. So I'll write this part out. So I get y equals 2x minus 3 over 2. It's okay that we have a fraction. Don't have your fraction phobia. Don't freak out. That is actually completely unnecessary for this problem. Right? The only thing we're worried about with this original line is its slope. So what slope did we have? 2. So our slope is 2. And it's a parallel, so it's the same slope. It's still 2. And then now we're going through this point 2, 1. So a lot of times I have students just cross out the rest of that because they're so tempted to use that negative 3 over 2. So just cross it out. We don't need any of that. All we were looking for was the slope. So we're going through the point 2, 1. So we have y minus 1 equals m, which is 2, times x minus 2. And that's it. Easy so far? All right. Good. All right, so same idea, perpendicular. Do you guys want to try it first? So find the slope. So all we are worried about is getting in that slope-intercept form, and we can find that single number, just the slope. So the slope for this line is negative 3/4. We can cross out everything else. We don't need anything else. So our new slope, what m value are we going to use? Yeah, we're going to flip it. So flip it over and make it the opposite sign of what it was. So it's going to be 4 over 3. So we're going to use that along with this original point. So we're going to get y minus a negative 3/4, so plus 3/4, equals 4/3 times x minus 1/2. Do you guys want to multiply it out and get it slope-intercept form? No, you guys should be like, no, no, no. Right? Stop there. We're done. So don't make things harder than they are. All right, let's see if some of you guys remember this from Algebra 2. So what does a y equal negative 4 line look like? So show me with your hands. Does it look like this, so vertical, or like this, horizontal? So I see you doing slanty. Come on. You're doing vertical. You're doing horizontal. We don't know. Okay, there's no x. This is y equals negative 4. So if you think about it, it's every point that has a y value of negative 4. So I could have 0, negative 4. I could have 1, negative 4, 2, negative 4, 3, negative 4. All of those points that have a y value of negative 4. So is it horizontal or vertical? Horizontal, like a horizon, right? So this is a horizontal line. And we want to be perpendicular to that. So what kind of line do we want? A vertical line. So is that an x equals or a y equals? An x equals. It's the opposite of what we had before, right? We're going to go through the point 2, negative 3. So 2, negative 3 is right here. So if we're going to be vertical going through that point, it's going to be an x equals, what's the x value? 2. So it's x equals 2. So there is a very quick way of doing this without sketching it out every single time. So look at these next 3 problems. So if it says parallel to y equals, well, if we're parallel to a y equals, aren't we also a y equals equation? What y value does our point go through? 6. So y equals 6 would be that one. Does it make sense? If I had said perpendicular to y equals 7, I would do an x equals, and it'd be x equals negative 2. So the next one, perpendicular to x equals negative 2 through negative 10, 52. So Lucy, what do you think? So perpendicular to x equals. Is that an x equals or a y equals? Nope. Why? Because it's perpendicular to it, right? So it's y equals. And what's the y value? 52. All right. Nat, are you ready? She made eye contact. That always means that you're ready. Usually you guys avoid eye contact at all costs. All right, perpendicular to y equals. So what do we need? You got it. Perfect. You guys get it? That's the quick way of doing this. All right. Almost done here. All right, Joey, look at you. You purchased a new Mercedes for $45,000. Easy, right? So Joey purchases a new Mercedes for $45,000. As soon as he drives the car off the lot, it decreases in value by 11%. I've always heard that it decreases in value by half. Have you guys heard that before? So Mrs. Hogan and I looked it up. We were like, how much does it really decrease in value by? 11%, around there. So after that, he knows that cars depreciate at a rate of 18% each year. I just made that number up. I have no idea. We can ask Mr. Walls. Do you guys know that Mr. Walls owns a car dealership? Yeah. So write a linear equation to determine the cost after t years. Okay, so as soon as he drives it off the lot, it's 11% less than what it was. So let's figure out that first. So take your 45,000. So if you guys have your calculators, what's the easiest way to find 11% less?
Do you multiply by 79?
Close, not 79 though.
89?
89. Yep. So we're going to take $45,000 and we're going to multiply by 89%. It's now going to be 89% of what it was before. So by 0.89. So 89% of $45,000. So I did on my calculator 0.89 times $45,000, and I got $40,050. Did we all get that? So that's how much it is at time 0, basically. So I'm going to write that as a point. So I'm going to say after 0 years, it's valued at $40,050. I'm not going to put that comma in with my 40,000. Well, how much is it after 1 year? How do I find that? Yeah, I'm going to multiply by 0.82, right? So 82%, 40, I'm just kind of writing some steps here. That got me, so 0.82 times 40, do you guys have the number? 32,841, yep. So after 1 year, we have 32,841. Okay, that's 2 points for us. That's all we need to do. If you have the equation of a line, you just need to find 2 points. And the SAT does this a lot now. They're real big into linear equations. They call it the heart of algebra. Heart of algebra problems are linear equations. I don't know, how much is it off of that? Well, we could have just done 0.18, right, times the 40. Or let's go ahead and find the slope. So let's find the slope. So we're going to do the 32,841 minus the 40,050, and then 1 minus 0. So when I subtract it out, I get negative 7,209. What does this mean in words? Yeah?
That's how much it loses value each year.
Exactly. So in calculus, you're going to have to talk a lot about units, and they're going to say, interpret this in words. So in calculus, you would say something like, each year, the car depreciates in value by $7,209. Those would be units, years and dollars, right? So for part A, it says, well, what's our linear equation? So our linear equation is going to be that y is equal to, we have our m, negative 7,209, x plus, do we know what b is? 40,500. Close. So it's not quite that 45,000 because we're saying he's driving it off a lot, and at time 0, it's really worth this, right? Kind of weird. It's like time 0.1 second later. So, yeah. Kind of weird. All right, so B, so how much will the car be worth in 5 years? So what do I do to find how much the car is worth in 5 years? Oh, I said in T years. Look at my units. I said T years. What should I do to adjust this part A? Yeah, make that X a T, right? So I'm going to put a little curly Q on it so it doesn't look like a plus. So I draw my T's like that. All right, so B, so how much will the car be worth in 5 years? We're plugging in T equals 5. So we're going to have y equals negative 7,209 times 5 added to the 40,500. Anybody have it? 4,500. Oops.
4,005, sorry.
4,005. Like that? Okay, awesome. That's not very much money after 5 years. Ooh. Especially for a Mercedes. Maybe I should adjust this problem and not have 18% each year. But whatever. All right, so then C. When will the car be worth $20,000 round to the nearest tenth of a year? So when will it be worth $20,000? What am I plugging in $20,000 for? Y. So you're going to do 20,000 equals negative 7,209t plus 40050. I'm running out of room. So I'm going to take that 20,000, I'm going to subtract out the 40050, and I'm going to divide by that negative 7,209. So I got t equals 2.78124566. So it says round to the nearest tenth of a year, so 2.8 years. Okay, does that make sense? All right, so you're driving on a road that has a 7% uphill grade. So approximate the amount of vertical change in your position if you drive 300 feet. Okay, so all that's happening here is we have a hill. We're going 7% uphill. And we want to find the amount of vertical change if we drive 300 feet. Now, where are we driving? Are we driving horizontally 300 feet? Vertically 300 feet? I should have probably specified. Let's say we're driving along that hill 300 feet. So you can find this a couple different ways. Okay, one way would be to use our favorite. You could use like SOHCAHTOA, but would you be able to use 7%? Yeah, you'd have to change it into degrees, so that's kind of weird. So let's think of it with equations of lines. So every foot that I go, I'm increasing by 7% of what I had before. So 7% in math, I write 0.07, right? X equals y. So I'm going to write it like that. So y is equal to 0.07x. Okay, so what happens when we drive 300 feet? .07 times 300. What do we get? 21. That's our answer. It was just 21 feet. So I guess I could think of it, instead of doing 7%, 0.07, like 7, for every 7 feet you go, you're going up. I don't know, you can think of it that way. Right? 7 over 100. All right, is that the end of that? Yep. All right.